But you also have these examples where it's a huge saving, and one is going underground, for example. And actually, the first customer that got the L120 20-ton wheel loader electric, then it was for an underground application. They have no other. I mean, they can only have zero emission down there. Mines have huge ventilation costs. Service machines going underground in mines, of course, the cost benefits as well as the health benefits are really big. So then there is actually a saving going electric already now.
Hello, this is Greg Schultz with Charged Electric Vehicles, Charged Off Highway. We're here for another conversation about electrification in off-highway equipment. Just as a reminder, if you haven't already subscribed to our channel, please go ahead and do so. Don't forget to check out chargedevs.com for more information on all things electrification. And you can also sign up for any of our newsletters there, both for on-highway and off-highway. So now that the pitch is done and I've remembered to do that, I'm joined here today by Fredrik with Volvo Construction Equipment, and we're going to learn a little bit more about Volvo CE's journey in electrification, how they're approaching electrifying off-highway equipment, and we really appreciate your time today. So why don't you tell the audience a little bit more about what you do for Volvo CE and maybe just give us a very high-level overview for anybody who's not already familiar with the company.
Of course, happy to be here with you today. My name is Fredrik Tjärnström. I work with the Electromobility Solutions sales team in Volvo Construction Equipment. And before I joined this team, I have 10 years background and experience within the technology, so the product development part of the company. So Volvo CE is belonging to the Volvo Group, and of course the largest business area is our trucks, but then the second largest is actually construction equipment. So within Volvo Group, we develop, manufacture, and deliver construction equipment solutions to the market.
Excellent. Well, thanks very much for joining us today. We certainly appreciate the time and the insight. So since we're here talking about construction equipment, and obviously our passion is electrification, why don't we start out by just talking about Volvo's journey in electrification? As I understand it, you've been a bit of a pioneer in that space. So maybe tell us about some key milestones in the electrification journey and kind of what motivated this transition from your end.
The motivation, the reason is, of course, climate challenge. That is one or the biggest challenge of our time. So the CO2 reduction is, of course, the main driver, but also other benefits that we see, like reduction of NOx and particles. That is an immediate effect on the health on the people close to the machines, can be the operators or the people in a city, for example. But you also have big improvements in operator environment, reducing noise and vibrations, etc. So there are many benefits of going electric, actually. And if you hold that thoughts for a minute and also consider that we strongly believe and we think that in a close future, the asset cost combined with the energy cost of running such equipment will be lower compared to diesel machines. And if you combine that insights, we absolutely believe this is the future. But you ask for the key milestones, and I think, of course, we have been exploring this for many years, actually. But of course, the main milestone, I would say, was when we 4 years ago introduced the compact range, the fully electric compact wheel loader and a fully electric compact excavator, because that's really the starting point. Being able to deliver this to the market. Then I think also 1.5, 2 years ago when we entered what we call the GPE segment, so the heavier equipment over 10 ton, and we launched our 23 ton fully electric excavator, was also an important step. But this is really not about maybe big steps. It's more like a continuous journey where we will, do more and more in this area.
Excellent. So you did mention a couple of areas where you've focused on electrification, but maybe if we can dive into a little bit more detail about what the current electric machinery lineup looks like. We've seen compact excavators like the ECR25 have been well received. So give us maybe a little bit more detail on what's available today in electric. And then, what feedback have you received from users as far as the performance is concerned, operational efficiency, etc.?
We basically first start in really high level from a technical perspective, how we will be able to go zero emission with our quite wide product range. we are pursuing different technical paths, so it's not only one solution to kind of fix this problem. It's the electric for sure, that we divide in kind of different paths as well. We have the battery electric, which is the one you think of first, and it's also the one we start with bringing to the market, so battery electric machines. But we also are investing in fuel cell technology, so having fuel cell electric machines. And for the larger excavators specifically that are quite stationary, we are also going into grid connected solutions, so you can minimize the amount of batteries you need on board. And long term, we also think there will still be a place for the combustion engine, but of course not fueled with fossil diesel, but with something else. Could be a liquid hydrogen, for example. So we are not betting on only one horse, so to say, or think that one solution will fit all here. So we're exploring multiple ways forward. And they can be optimum for different machine sizes or machine types, but we also are a global company, so there can be regional differences. Volvo cannot control if some part of the world will invest in hydrogen infrastructure and others will go more into the electric grid, expansion. So we must be a bit open here for what will be the future will tell, which will be the dominating solution. But I think also maybe we will see multiple different solutions for different regions, different products, etc.
Absolutely. I think that's really crucial to the success of these initiatives, right? Is that we do need, especially today, right? We need to be somewhat flexible in terms of how we address these solutions, because as you mentioned, not every region is the same in terms of their access to infrastructure and technology. But the use cases aren't the same for everything. So you mentioned stationary applications where we can just plug into the grid. And I love those kind of solutions of, really tailoring what we're offering to how the equipment is used. There are situations where battery electric, even today, is already just a great solution for the way the equipment's being used. But there are situations where that's not going to be the right answer. And I think being flexible and understanding that is going to be crucial to adoption. But continue. You were about to say something else.
Yeah, that's a good summary of our view, actually. But how we go about it then is a bit. You could argue that compact machines doesn't emit so much CO2, so that's not the where to start. But we always have the ambition to do as much as possible as early as possible. And 4 years ago, when we launched, and then you can imagine we started the development much earlier than that, the technology maturity was not there for larger machines. So we start with a smaller range, and then from there we expand. So we will, of course, and you can see that through the years we have, offered larger and larger machines, but we will also, of course, expand the machine types. So as I said, this is a journey. The starting point was from the smaller end, and then we will grow with time here. However, having said that, yes, it's true that the compact machines doesn't emit so much CO2. However, the legislation on the engine side is, the fact is that the smaller machines does not have an after-treatment system. So they emit quite a large portion of the NOx and particles, which impacts, the health situation. So combine that with that the compact machines are mostly used in city environment, close to people, basically. That's an important factor as well.
Absolutely. And they can even be used indoors where the noise factor is going to multiply, right?
Yes, and this indoors, it changes how our customers can use the machines, of course. And you see examples where they can remove one diesel forklift indoors and the outdoor diesel wheel loader, and they just need one electric wheel loader to do the work because they can use it both indoors and outdoors. It gives also new opportunities how to do things, actually, which is great to see.
Yeah, that is exciting too, and that's something we actually haven't touched on in previous conversations, is how you may be able to get double usage out of a piece of equipment, because a lot of the concern or some of the comments that we'll see on some of these videos is, okay, yeah, but you're not talking about how much that piece of equipment costs up front. And it's like, well, okay, sure, sometimes new technology is going to be more expensive up front, but things like you just mentioned, where you may be able to replace two pieces of equipment with this one piece of equipment. So even though the price point might be higher initially than a single piece of internal combustion equipment, if you're replacing two pieces of equipment with that, your actual cost is lower. It's things like that the end users of the equipment need to understand that.
Absolutely, because today we're not, I said in the beginning that we are convinced that we can, the asset cost combined with the energy cost will be lower in the future. We're not really there today. We have examples where we are. If you have high utilizations, for example, you run a 2-shift and quite tough work, so you consume a lot of energy, then we have cases where you are actually on par on the cost. But in general, we're not there. But you also have these examples where it's a huge saving, and one is going underground, for example. And actually, the first customer that got the L120 20-ton wheel loader electric, then it was for an underground application. They have no other. I mean, they can only have zero emission down there. Mines have huge ventilation costs. Service machines going underground in mines, of course, the cost benefits as well as the health benefits are really big. So then there's actually a saving going electric already now.
So we've mentioned kind of on the small side, and then you mentioned that you are electrifying some larger pieces of equipment. Can you go into a little bit more detail in terms of what equipment today is fully electric? And you can definitely let us know about fuel cell technology, grid applications, anything like that, hybrid applications, just anything that's been kind of electrified on the equipment side, and then also how that equipment has been received from the people that have already adopted it.
Yeah, so let's start with what we're not doing, and we're not doing hybrid. We didn't see that the increase in cost and product complexity was, gave enough fuel savings. So we kind of directly jump into the zero emission and full electric solutions. Today on the grid side, we can offer rebuild machines that internally with our companies that we own and external partners as well. But that's not really an industrialized solution. But on the battery electric, it's industrialized, designed for mass production. And we have a compact range. Globally, we offer about 20 different solutions today. If you take the European perspective, we have the 5 machines in the compact range below 10 tons. And then we have started delivering this 20-ton wheel loader this quarter, actually. And a couple of years ago, we introduced the 23-ton excavator that is now coming in a second generation, actually, improving it. But later on this year, we will launch a 15-ton wheel loader, and beginning of next year, we will start delivering a 15-ton wheeled excavator. And if you come to Bauma, I can show you some really interesting other news that I cannot talk about today then. But in April, we can come back on that. So as I said, this is a journey, and we are expanding machine sizes and machine types as we go.
Excellent. Yeah. Audience, make sure you're tuning back in around the April timeframe to see more potentially live from Bauma. So how are the machines being received in the field? What's the kind of feedback you get from the customers that are already adopting and using that equipment?
It's a lot of positive, but there are some challenges for sure. You shouldn't, hide from that. If you do, now I'm generalizing a bit, of course, but often there is hesitation before, especially from operators. I could say that they don't trust that they will be as strong or can do the job, so to say. But that is quite quickly, if you just try the machine for a couple of days, you understand that you can do the same work task. It's as strong and powerful as its diesel equivalent machine. So that is quite easily to overcome that hesitation or doubt, or what you want to call it. Then they really appreciate the operator environment. I mean, the silence, and if they use it for a longer time period, you also acknowledge the less vibration. So you take the 230, for example, then the excavator. It has 1/3 of the noise and 1/10 of the vibrations. You feel less tired after a working day, etc. So it's a big improvement for them. Their colleagues on the work site also appreciate this, of course, because less exhaust and less noise, etc. And the people living around the site are also less affected. So that's like the micro view of it. From the contractor perspective, or the one running a project or whatever, they acknowledge the reduction in CO2, of course, less cost for energy. Electricity is, first of all, they are more energy efficient, but then also electricity is, in absolute majority cases, less costly than the diesel. So that's all good. What is the challenge, I would say, is to find a process or a procedure, or what you call it, a schedule or whatever, to manage the charging in an efficient way. Because, of course, the key to make this, maintaining the productivity, you need to be able to charge on breaks or during night, or when a diesel machine is idling, so to say. I mean, our equipment is often quite high in idling, and this is waiting time. If you can utilize that for charging, you don't lose production. So that is kind of the key challenge, to rethink a bit, or maybe plan a bit more in detail, and also finding a way of working that allows you to charge without losing production time, basically. That's the main challenge. Of course, in addition to that, then, and also connected to charging, they need an extra component grid. And in some parts of the world, that can be very frustrating. If you work in central London, for example, of course, there is electricity everywhere,
right,
but you're not allowed to access it. There are sometimes limitations or obstacles. Sometimes it's just knowledge, or you're not used to having that challenge, or it's mixed. But to be able to connect to the grid is often a challenge.
So have you heard any feedback from the people who have run into those challenges about how they're addressing them? Any kind of best practices maybe that you've found that others could utilize?
Yeah, first of all, best practice. Yeah, what I see in the successful cases is that they have a bit longer planning horizon maybe than normal. They have really thought about this part of it as well. I mean, it's a big change. In the diesel world, you just put call for more diesel and someone delivers to you, and you can get as much energy as you want, basically, even if it costs and pollutes. But when in the electricity world, often you need more planning, and maybe applying for this permission to connect to the grid more in advance, etc. And also, you can make it easier or more efficient if you also consider how you run your product. Maybe you can replan a bit. You can have a more even out the power and energy need during the total project phase, or you can maybe in a building project, often they do electricity last. Maybe you should start with that, so you can install a charger to have electricity, etc. So there are, normally the ones that plan and really considering this, and also are prepared to maybe adopt their behavior or way of working to accommodate these new technologies, they are more successful, I would say.
Sure. Do you find that 'cause we when we've talked to other equipment manufacturers at times about these kind of concerns, one of the big things that often comes up is that kind of range anxiety that fleets will have of, can I actually get through my working day without needing to stop and wait for the equipment to charge? And one thing other manufacturers have noted is it ends up being less of a concern than they thought it would be originally because the equipment is not consuming power during that idle phase that, where a diesel engine would be running the whole time it's running the hydraulic system. In some pieces, certainly of electric equipment, there isn't even a hydraulic system. It's electric or electronically actuated. And the thing that it takes the operator a minute to adjust to mentally is it's not consuming power when you're sitting in it. It's only consuming power when it's actually doing the work. So is that something that you've also noticed, or does that vary a bit? Are there some situations where the range anxiety actually it's a real valid concern and they need to actually change the way they're working, or a lot of them can just get through the workday as they normally would have, and then the charging maybe becomes more necessary at night when the equipment's not even being run anyway?
It is a valid topic, I think, because also the range is varying a lot depending on what you do with the machines.
Sure.
And how much idling you have. Or you don't have idling, as you say, but comparing to a diesel. And this varies a lot. I mean, if you look at our customers, of course, an average is typically 30% for medium-sized construction equipment. But of course, it varies. Some have 5, 10. They are really productive and efficient. Some have 50% or more. And especially in the smaller range, you see a lot of this waiting time. So it varies a lot, and that affects a lot, but also how tough you run the machine. If it's a low or high duty, makes a big difference. So it is a valid concern. We don't have our full product range at the moment, so maybe we don't have the optimum machine yet for every task, etc., or work, or what you want to call it. So then you can also come into these challenges that you try to do a work task that you, in essence, you would need a bigger machine, for example, and then it starts to consume a lot of energy and you lose production time, and then you're not a happy customer. So our advice is that start where it's really feasible. Don't start where it is most difficult.
Sure.
Of course, I mean, I often met people having doubts, and they bring up this road construction example in the middle of nowhere, really, far from electricity, etc. And I like, yeah, absolutely, that is hard. It will be possible in the future, but we're not there yet. So don't start there.
Right.
Start when it's feasible, where you can access electricity, etc. The second point on this is, are you sure there is no electricity? Because often people say there is no electricity, but they haven't looked for it. We have, investigated, because this road example is really this. It's very common. And we looked through 3 typical road projects in Sweden, and we found 2 megawatts on all of these. So it's not that, is it really true there is no power? And the third aspect of this, we are improving our products. More and more of these products, the L120, the EC230F, the EVAR 150, they will all, in the absolute majority of customer cases, they will work for one full shift without charging. So then it becomes easier as well. So we will learn, and the technology will improve, and it will get easier.
Yeah,
really soon as well. So
absolutely. So we're kind of starting to get into this, but this was actually one of my next questions was, if we dive a little bit more into specific models, the EC230 is kind of a notable addition to your lineup, right? So how does this model specifically cater to the needs of kind of the larger construction projects that we've just sort of started to touch on here?
230 size, this 23-ton size, is a quite popular machine size. It's one of our really high runners, so to say. So it's commonly used, but maybe more in should I say, larger utility projects or smaller to medium-sized ground preparation work, etc. But it's not really the machine to do, big ground prep works or go into quarries, etc. So that we're not really there yet, but we are moving in that direction. So very soon, but maybe not the 230 then. The wheel loader is a bit the same. Then an L90 is very popular machine size used for, in many cases, as some service machine or material handling, and in mines as a service machine, not a production machine then, but also a lot in city environment. EVR 150 is for sure a very versatile machine, very popular for utility works in cities. So that we believe a lot in that product type, so to say. So we're not yet into these big road projects or big excavation, moving a lot of material, but we're getting there.
Sure. Yeah. And it kind of goes back to the point you mentioned earlier about focusing on where electrification can deliver the most benefits. And then in areas where the tech just isn't there yet, not trying to kind of force feed it into those roles. Right. And I think that's I like that strategy because, particularly, if people couldn't tell based on my accent, I'm US based, and certainly the U.S. market, I think, responds a lot better to offering a product because it's better for what people are looking to do, rather than trying to say, you need to use this thing because we're telling you to use it. So I think the mentality that you're taking into this of where does electrification really offer the most benefit for the user? Where are the areas where we're not quite there yet? Maybe stick with what you've got. I like that philosophy, and I think that's got the best chance of being successful, certainly here in the U.S.
Yeah, we often argue that, instead of going 100% zero emission in large projects, it's better to do 10 projects with 10%, so to say, where it really fits and it's not so. Why do it so bloody hard if you can do it easy? So that approach, and we will offer more and more, so you can do more and more. But having said that, we can do a lot more than what we are doing as an industry. We are far from doing what we can. But to give some kind of perspective where we can do it successfully, I can give a couple of real examples, so to say. We just finalized a project in northern Sweden here, building a preschool. So it's a small building project, like $10 million project. And they targeted 95% emission free, but it succeeded with 97 actually, which is a lot. That's very, very close to 100. It was just a compactor. They couldn't find electric at the time, so they couldn't do it fully electric. But 97% emission free, and the additional cost compared to what they budgeted for diesel is 4% on project level. But then, 4% is actual. They compare it to the budgeted price, and we all know that building projects have a tendency to kind of stretch budget a bit. They had no delay at all, perfectly according to time plan. It was in northern Sweden. We had a lot of snow that winter, last winter, and some days was minus 30 and minus 20 was not uncommon. So that was clearly possible, I would say. Then we have larger building projects, developing new parts of Stockholm, for example, where they build residential areas, offices, restaurants, etc., new roads, sewage, everything. They are now in the second phase on 50% emission free. But they don't go 100 because that would cost a lot more, But the first 50, it's easy to take. So I think that's a good approach and gives you some perspective. But then, like this L120, if you put that into a 2-shift operation, the cost looks really interesting if you include the running costs. So we can do a lot more than what we do today, for sure.
Yeah, and the point you made just a second ago regarding the temperatures, that preschool was built, and that's a comment we've seen on other videos is, oh, let's see how this equipment performs in the cold. It should be noted there are some temperature issues when you're operating diesel equipment in the cold, but that's
yes.
you could, that's an understandable concern, right? I mean, we've all heard that, a battery is not going to function at its best outside, when you get into temperature extremes, but obviously the equipment was able to complete that job. Do you have any more detail on how that worked, or, did they run into challenges that they had to overcome, or did the equipment just work pretty well in that situation?
The challenge was not around the electrification. When it gets that cold, as you say, you get, hydraulic oil gets very thick, and you have some mechanical issues as well, but it worked. These machines, we designed them with active cooling to the batteries, but also active heating, actually. So we temperature control our batteries to get, the best performance, but another important aspect of that is the battery life. If you take care of them well, the life of the batteries prolongs a lot. So, but it's also to allow for multiple, go 3 around the clock operation. You should be able to run and charge and run and charge and run and charge, and and not building up too much heat in the batteries. So that you need to do. If you want a long life on your batteries and be able to operate in all this in a wide temperature range. But we also, L120, we did a customer test in Dubai, plus 40, that worked well as well. So it's a valid concern, but you can manage it.
Yeah, absolutely. And I think that's certainly our audience probably understands a lot of that, but that's certainly something that we hope people who are actually in the process of evaluating what piece of equipment to buy next are going to keep in mind, is that, engineer, if you're aware that the temperature constraints on a battery are important, the engineers working on these applications are very well aware of that also. And the companies making this equipment are very well aware of that and are already implementing solutions to make sure that very real concern is not going to manifest itself when you're trying to utilize the equipment. There's already a solution in place. They know you're going to be using it in hot environments. They know you're going to be using it in very cold environments, and there's solutions already available to make sure that you're still going to be able to get through your workday. But so I think at this point, if you don't mind, we'll transition the conversation a little bit. We've kind of talked at a high level about what sort of equipment we have available today, kind of benefits and legitimate concerns for electrified construction equipment. If we can, I'd like to dive a little bit deeper into the actual design process for this equipment, because a lot of our audience members are engineers, they're product development professionals. They're working through these challenges today, so the insight you have might be invaluable to them. So can you tell us a little bit more about that development process? For component systems such as electric drivetrain development, for example, do you design that in-house, or is that something that you're sourcing externally as it stands today?
No, but it's mainly in-house. The batteries, we buy the modules. So we have a partner, Samsung, that supplies the cells and the modules, and then we assemble the actual battery. We build inside Volvo. So we have two assembly lines for that, one in Belgium and one in Korea. But the drivetrain we develop ourselves. The electrical motors is sourced, but I think the biggest advantage maybe we have is belonging to Volvo Group, because there is a lot of shared technology with the trucks. And they're a bit ahead of us, must be honest to say. They have the complete range fully electric already today. But what is good being in this group is that if you take I talked about the L90, they were around 50 and the EC230. They all share the same EMOB platform, so to say, when it comes to the batteries, the electric motors, the inverters, etc., the cooling systems and so on. But it's not only that they share it internally within construction equipment, it's actually the same components and architecture as for the trucks. So it's the same batteries, electric motors, and power electronics that we can share across not only different product types within construction equipment, but also with the truck side. So that's really good for us because, of course, it's a massive effort and cost investment for us to do this transition. And if we can share this within the group and across more products, it makes it easier, so to say.
Definitely.
So that's good. But then the architecture as such of the machines, I don't know, comparing to car industry, then we're at the same strategy as BMW, you can say. We have, or many other cars as well, that we share the same architecture for the diesel machines as for the electric. So the axles, the base design of the transmission is the same, the hydraulic system is the same, the cab is the same, etc. But this also allows us to produce them in the same production lines and factories as the diesel equivalent. So we are well set up, I would say. First of all, we serially produce them in a controlled environment, and all that comes with that when it comes to cost and quality. But also we are prepared when this takes off. We can really scale this and we can expand quickly. But we're not at the point where we have dedicated architecture and design, optimizing the electrics. We're not. That will come in the future, of course, when the volumes are rebalanced. But now the electric, unfortunately, are at we think too low level, but this is a way to control this and coexist in the factory.
Sure. Yeah, that makes a lot of sense. So if we talk, I'm actually somewhat intrigued to hear that you can borrow a lot of the technology from on highway and utilize it for off highway, because the use cases, where certainly somebody like me often thinks it's very different use case, and configuration wise, there can be a lot of things that need to be changed because there's so many different models of off highway equipment. But you don't find that presents a large challenge, or it seems to be something you've clearly been able to overcome if it does.
Absolutely, we can overcome it, because a lot of effort in the development projects is to secure that the components and system will survive our environment. That's a valid, concern. And we spend a lot of effort in how to mount the batteries in the frame, for example, and how to dampen the vibrations, etc. And a lot of tests, simulations, lab tests, etc., but also real machine tests, of course, to verify that it's okay and the levels are within the specifications. So it's not just to take it and bolt it onto the frame. You need to give some thought into it. But it's absolutely doable. When it comes to electric motors, for example, it's a different way of thinking compared to diesel, because in an electric world, the power is really cheap, so to say, and we can share the same motors. It's better to go for volume. So, maybe L90 and L120 is a good example then. On the L90, we have L90, EC230, L120, and the trucks. They all use the same electrical motor. In the L90, we have one for the hydraulics, one for the propulsion. In the L120, same motors, one for the hydraulics, but two for the propulsion, because we need a bit more power and torque. So you can kind of modularize the design a bit. And of course, with D-rate in the L120, we don't need the power of two. We need 1.5 or something. I don't know the exact number, but you D-rate that with software. But it's a more, you get more higher volumes on the motor, so you get better quality and better cost, and it's a smarter way of doing it. In addition, we decouple the systems then, so there is no longer the alternative would go more similar to the diesel, that you have one big motor that should supply the energy for all systems. But if you do it like this, you can remove the converter, and that cause a lot of energy loss. And by decoupling hydraulic system with the propulsion, you use the energy when you need it, so you reduce losses even further, and you get, you get the power when you need it, but not otherwise. which is a big advantage. So it's not only about putting batteries into the machine, it's also making the machine systems more energy efficient to get more runtime. So it's a combination, of course.
Yeah, absolutely. Speaking of the electric motors, do you find that there's certain motor technologies that are a better fit specifically for off-highway use cases and configuration requirements? So, things we think about are axial flux versus radial flux, permanent magnet versus induction. Is there anything that you've found that works best in the off-highway environment?
Today we use permanent magnet and high-speed motors to get the size down and less material, etc. And we can do this decoupling of the systems and distribute the power to more specific uses, or how to put it. But of course, we are continuously looking into different motor technologies. It's not only the power and the cost, it's also about the sustainability part of it and what materials you use, etc. So that's an ongoing work, I would say, but today we use the permanent magnet motors.
Excellent. And as far as the harsh operating conditions that construction equipment especially is exposed to, but not only construction equipment, I mean anything in an off-highway space, agricultural equipment can certainly be exposed to harsh operating equipment or harsh operating conditions. So what are some strategies that Volvo CE has developed for, we sort of talked about the temperature earlier, but for thermal management of batteries and power electronics? Obviously, that is a huge topic in electrification. What's been your company's approach to that so far?
Our approach is that, first of all, the batteries we are targeting to really take good care of in the machine. But the cooling systems gets more complex for sure. I mean, you need one for you could say you need four in the machine. You need one for the cab, you need one for the batteries, one for the power electronics, and one for the hydraulic system. And they all work in different temperature ranges, etc. You can, but our approach has been to accept and develop a bit more complex cooling system to get better performance and life out of the systems, and to be able to operate in this wide temperature range that our customers need to be able to do. So we, as we mentioned earlier, we have active cooling and active heating on the batteries, and we manage the hydraulic and power electronics separately because they want different working temperatures. So we optimize the cooling system for each part of the machine systems, which bring a bit complexity, but we believe it's the best way forward to get the best performance, basically.
Yeah. Are there any materials or cooling technologies that you're currently testing to improve that heat dissipation and get more longevity out of those powertrain components?
It's a bit, to be honest, it's a bit detailed for me. I don't know exactly what they're investigating. The general answer is, of course, yes, but unfortunately, I don't have
no problem at all. No problem.
But doing like this, separating the cooling system, you also control it. It's also energy efficient in the way that, I mean, you have electric fans, so you never, instead of one big hydraulic fan, for example, so you only have to consume energy for the cooling system where it's needed. So if the hydraulics get warm but not the power electronics, you run only the fans for the hydraulics, etc. So it's also a way of improving energy efficiency of the complete machine, so to say.
Excellent. So moving back, I guess, to the kind of the customer side of things, how have the current customers kind of responded to this shift towards electric machinery? Do you have any kind of success stories or any notable feedback that you can share?
I would say general feedback is that great to use the machines, very smooth to operate, a bit quicker in response. They appreciate that. More silent, no emissions, of course, but the challenge is how to charge. So that's like in that perspective. But then, speaking of good examples, I just must bring up Oslo, or city of Oslo, that in 4 years, they have gone from 0 to 77% emission-free projects in projects ordered by City of Oslo. Not all projects in Oslo, but projects ordered by City of Oslo, which is, of course, a big part. And that, I think, really shows that it's possible to do so much more than what we do today. If you talk to City of Oslo, they say that they during these years, they've seen that the costs have gone up 4%. If you talk to a procurer of City of Stockholm or Los Angeles or whatever, these years has been quite, a lot of inflation.
Absolutely.
And cost increases in general, etc. You could argue it's maybe a saving, but that's what they say. I talked about this preschool. I think it's a good example how far you can go as well. But in general, we as Volvo, we think this goes too slow and we want to do more. We think we do our part. We deliver more and more solutions to the market. We try to support the best way we can with charging solutions as well. But I think one of the challenges is that you cannot do this in isolation. It's not enough that we do it, and it's not even enough if our competitors is doing it in parallel. It's a whole ecosystem that needs to change or adopt or transform, or what term we want to use. I mean, we need green electricity, we need access to the electricity, is easy to access and connect to the grid. We need the supply chain that can deliver all these components and systems. And we need a demand. We need, a real pull. And it's kind of shifting towards that, but it could be more. And one of the challenges is also often in our industry, there's a very complex value chain. There is, someone ordering the product, the main contractor, subcontractor that use subcontractor in its turn. So it's both very deep value chain, but also very broad. And often today the ownership of the machines is quite, on small company level. And to be honest, the demand comes from higher up the value chain, from the big construction companies with a strong sustainability agenda, or like the party ordering these projects, cities, for example. Then at city level, you really have this pull, but they don't operate machines. It's a subcontractor
Sure.
that operates the machine. And that's a challenge. It slows down the whole change process here.
Absolutely. Yeah, and so you touched on this a second ago, and we've actually touched on it a few times during this conversation. So no conversation about electrification of off-highway equipment, or really electrification of any equipment, would be complete without talking about the charging infrastructure and solutions. So obviously it's going to be a critical element for fleets adopting, or whether that's a construction a construction company adopting the fleet, or rental. A lot of equipment, certainly on a construction site in the US, is rented rather than owned. But fleets that are using internal combustion equipment today are going to be concerned about how they'll be able to charge that equipment once it's in the field. But I believe Volvo launched some solutions for this at ACT Expo. So can you give kind of a quick overview of what is available today? And then maybe, if you're able to, give us kind of a window into the future, a little bit of how you envision this evolving.
Yeah, sure. No, but first, just to admit that we underestimated the need of the charging solutions. In the beginning of this journey, we only focused on the machines, to be honest. But we learned very quickly in the dialogues with the customers when we launched the compact equipment that they didn't ask so much about the machines, to be honest. They asked, how should I charge it? So we tried to improve, and we have now a charging organization, and we have established an initial charging portfolio. We don't manufacture it ourselves, it's via partners, but we think it's important that to support our customers in this transformation, we must come with a total solution, a machine and how to charge it as well. So trying to describe the portfolio in an overview. First of all, there's a difference between the compact machines and the larger GPE machines, and that's the voltage level. So the smaller ones run on 48 volt systems, which does not have a charging interface standard. So each brand has its own hardware and software interface. We don't think that's good. We don't want to be captive in this area in any way, but that's just the way it is. There is no standard. What we have done is we have published our charging interface on the internet. So the specifications are available for anyone. If you are a charging supplier, you can go ahead and make a Volvo adopted charging solution, because we want to make it easy to charge our machine. Of course, you can buy this from us if you want. For the larger machines, we go with the automotive standard. So there's CCS2 in Europe and CCS1 in the States, and GBT in China. So it should be easy. You should be able to share your charging infrastructure. And today you can do that between your electric truck, your car, and your construction equipment. It makes it more cost effective, but it's also, of course, much easier. So, but also here we have a charging portfolio to offer. And in principle, you could say we have 4 different steps in this. It's the overnight charging with the AC cable. You just plug it in. If you have a long time to charge, you can do it like that, low power. We have a low power DC option. Also, you don't need an electrician. You can plug it in if you have some building power or some higher power connection plug. And then we have DC fast chargers, so high power chargers that you need. It's a fixed installation in the aspect that it's not a plug and you need an electrician to do it. But on the other hand, it's not many hours work. So I think on a site, or you can move it around occasionally. You don't have to envision several years to install such a charger. And then the final step is what we call power units, which is in essence a box or a container with batteries and fast charger integrated. And the main use case is probably that you slow charge it continuously, and then you can fast charge from it when you need to. So the batteries are continuously charged, and then you can take a lot of energy in a short time, and then it's slowly charged back again. Or you can use it as a power bank. You can charge it overnight, bring it to your site, and then take it back for charging and go back and forth. That, to be honest, comes with a cost, of course, but it's technically you can do it. So that's like the charging portfolio setup. Then there are several performance steps and different alternatives and different regions and different brands, etc. But we can support with charging as well. And yeah,
excellent. Well, that's great. So now that we've kind of covered some of the engineering hurdles, we've covered kind of where electrification is today with Volvo CE's portfolio, a little bit of the feedback of what users are seeing when they adopt it. Looking into the future now, what is Volvo CE's view on the future of electrification in off-highway, and specifically, what are some of the hurdles? I know we've talked about some, certainly, but what are the hurdles that you still see that we need to overcome to increase innovation and adoption? And then what are, if you can give a couple of examples of how Volvo is working on addressing that would be even better. Those are bonus points.
That's a lot of questions in one there. But considering the future, we will continue this journey. We are very firm on that this is the way to the future. There are some obstacles or hurdles, or what you want to call them. Maybe the main challenge is how to make this entire ecosystem we talked earlier about to move in parallel. Because it's not enough that one part of the chain advances. I mean, we need to do this together. And that means our competitors, energy companies, customers, contractors, everyone involved in the industry. But we will continue. We will launch more and more products and solutions, bigger machines, more machine types, etc. So it will be more and more that will be possible. But just as a reminder, there is so much more possible today, and I think that's important to keep in mind. So maybe the most important thing doesn't have to do with technology or what chargers you have available or whatever, or the value chain. It's basically about people need to dare to try. Because we see that if they try, they see that it works, then it takes off. I mean, Helsinki City, they did 3 projects, they see it works, they implement requirements, and they go. Ellevio, big energy company based in Northern Europe, we tried a couple of projects, they see that it works, they put in requirements, and they tell the contractors, every excavator under 3 ton just have to be electric. There is no other way. So dare to try. That's what I encourage everyone involved. You can do so much more than it.
Yeah, and I think the success stories will go a long way in motivating others to be willing to try, right? It's all well and good for us to believe that this is the right path forward, and obviously you're talking to a publication that's dedicated to electrification. We certainly believe that the future is electric. Yeah, we're evangelists, so we're preaching to the choir, but the reality is when people see that they're able to get the jobs done, they're able to get where they need to go, they're able to accomplish the tasks they need to accomplish, and especially when they see that either the process of accomplishing that task is more pleasant and it's more cost effective in a number of cases, that's going to go a long way to increasing the adoption. And when we keep having these conversations, we keep hearing these stories. And that's why I think, the importance of getting these conversations out there for other people to hear is really going to go a long way, and also increasing that adoption, because there are people still out there today who are hesitant. They have concerns. Some of those concerns are understandable. Others are more easily diffused, such as I'm not going to be able to get through my workday. We've already talked about how that's often not actually the case. They are able to get through the workday. So, having these conversations is an important piece of that puzzle, I think. And to that end, we really appreciate you being willing to talk to us and join us and tell us a little bit about Volvo CE's journey. We're certainly interested in continuing to have these conversations. So hopefully as events unfold, you'll keep us posted and we'll be able to share that information with our audience. Hoping we'll be able to do so at Bauma as well. So if there's any final notes.
No, but you're of course welcome to Bauma. And yeah, actually our entire booth will be only electric lineup. So we will show only electric machines at Bauma, and we have some exciting news coming up. So I hope to see you there.
Yeah, that sounds great. I'll look forward to that. For anybody who has been intrigued based on everything that we've discussed today, where can they go to learn more information about Volvo CE's journey to electrification?
Yeah, volvoce.com for sure. But you can always reach out, to your dealer or to me as well. I can point you to the right people, right region, etc. But volvoce.com is a good starting point.
Outstanding. Well, Fredrik, thank you very much for joining us again. We really appreciate it. Look forward to conversations in the future. One last time as a plug, if you enjoyed this conversation and you'd like to hear more like it, make sure you're subscribed to our channel here on YouTube. You're checking out Charged Off Highways long form and short form conversations, and make sure you check out chargedevs.com for all electrification news and updates. Subscribe to our magazine newsletter if you'd like. And that's all for today.
Thank you for having me. It was a pleasure. See you later.